Okay, let's start working on the practice exam and see how far we get. I think we get through 4 or 5 questions. All right, so first off, they're giving me some information, blah, 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 blah. We don't need to read all that stuff. All that matters is this. They're giving me capital A is 75 degrees. Little a is 4 and B is 8. And they want me to find if there's 2 triangles or 1 triangle or no triangle and what angle B is. All right, so let me give you just a second to think about what you might use on this question. Because that's a lot of the battle, isn't it? On these tests is which thing. There's so many different things we learn, you know, and then the test like puts them all together, let alone the final in only 10 days, puts the whole course together. So like how do you identify, a lot of the battle is identification. So you look at this question, how do we know which one to do? Zuhal, how do we know?
Because we have capital A and small a, that's why.
That's it? Yeah, that's right. Right? We called it a complete set, right? Wasn't that Jose's term? Complete set. So yeah, complete set. So see how we have A with A? When you have A with A or B with B or C with C, you have a set, you have both of them. That's when you're going to do law of signs. So if you have both A's or both B's or both C's, complete set, use law of signs. When you have a complete set, use the law. Now, if we didn't have that, we would use law of cosines, huh?
We get to use the calculator on the whole test.
Whole test. Did you notice that? Part 1 and part 2, calculator all the way. And the calculator has all the answers. You don't even need to study. Just bring a good calculator. It's all good. I'm kidding, right? You know better than that, right? These are stupid. You have to be the one to tell them what to do, right? All right. So, all right. So use law of signs. How am I going to use the law of signs? Remember the law of signs? A over sine A is B over sine B. Remember A with A, B with B, C with C. So I'm going to use, what is it? 4 over sine 75 is 8 over sine B. Good to there. A over A equals B over B. And you go diagonal, diagonal. 4 sine B is 8 sine 75. We good to there. How do we solve for, well, we divide by the 4 first. Boom. And then we get, what do we got sine of B is 8 sine 75 all over 4. Good to there. You can cancel 4 into 8 if you want. It doesn't matter, though, because I'm just going to do what now? What am I going to do to get B? Sine inverse, huh? So you can just do that. Sine inverse, these cancel. So B equals whatever the sine inverse of that whole thing is. I'm getting, whoop. Oh, error. I said, whoops, I thought I messed up. No, it's error. I'm getting an error when I do that. What does that mean?
No triangle.
None of the above, right? No, careful. It's not none of the above. It is one of the above. You're right. You guys are right. It's no triangle. So don't be fooled by that. Yeah. No, it's not none of the, no, it is. Yeah. It's no triangle. That means there's no triangle that fits that situation. That's what the error on the calculator is telling you. That's not possible. That kind of triangle is not even possible. There's no triangle that fits that. You might think, well, then how could it ever be none of the above? Well, it could be none of the above if it was 2 triangles but a different B, or 1 triangle but a different B. And that would be none of the above. Right? All right, we good? Move on to number 2. So make sure you get error on that. Okay, try that one. Give you a second. Rather than me diving in, I want you to do the identification thing, because that's a lot of the battle. is identification. So give that, look at that thing and decide what to do. All right, what important words tell you what you're supposed to do? Find the area, yeah. It's easy to miss that. When I was doing it earlier this morning, I missed those words, started doing something crazy. Yeah, find the area. Find the area. That's different, huh? That's a different kind of question. It's not find the lengths of the sides and all that kind of stuff. It's find the area. What now on your paper you'll have an area formula which says 1/2 times like side 1, side 2 times the sine of angle theta, where theta is between the sides. I don't remember exactly how I wrote it off, but maybe I just wrote 1/2 AB. Is that what I wrote? Maybe I just wrote 1/2 AB sine of theta, where theta is between A and B. It's definitely sine. It's always sine, and it's got to be the angle in between. Well, it is. B is between A and C, huh? So it'll work. It's 1/2 times 4 times 7 times the sine of the angle in between, sine of 10 degrees. I'm getting 2.43 rounds to 2. There we go. C. We good? Remember that formula? 1/2 AB sine of the angle in between. On we go. This one is tricky. Can you read all those little bitty words and figure out what in the world that thing's talking about? Drawing the picture on this one is worth everything. I think if I gave you the picture, you could all just nail it out, no problem. The hardest part of the battle is coming up with an accurate picture. So let me give you a little bit of time on this one. Let's do that. Let's think about the picture. So I'm going to draw this plane going straight here. So let's say this is the plane right there. Let's say he's headed north, straight north, whichever direction, doesn't matter. And then it says he observes a mountain at a bearing of 32.5 degrees to the right of its course. So that means there's this mountain. And the person is on his course, and he looks to the right of his course, right? 32.5 degrees to the right of its course. So that means this right here is 32. I'm not drawing that very well. Is 32.5 degrees. This angle is 32.5 to the right of the course. See what that's saying? Does that make sense? Were you able to come up with that? If not, do you see now how you can do that kind of thing? So that'd be like me saying, hey, I was headed on a course, and then I looked over to Clarence, and he was, 30 degrees off my course, to the right of my course. So that's what they're saying. So the plane is headed straight up, or straight somewhere. And you think, well, it doesn't have to be up. No. What if I do I could go straight to the right. The plane could be headed here, and then he looks off to the right. That's still to the right. And there's the mountain. Right, here's the plane. That'd still work. At 34.5 degrees, or what is that what it was? Yeah, 32.5. Anyway, you could do it anyway. You see what I mean? It doesn't matter what direction you start with. You could have started straight to the right, and then this is right. This would still be right of your course, right? If you were going this way, this is to your right, isn't it? So it doesn't really matter that I went north. Any direction's fine. You could say the plane's going that way to begin with. Okay, great. There's the plane. Then this is, here's the mountain. This is to the right. Whatever. It doesn't matter. It's just easier to go north, I think. Everybody seeing the idea? So it's headed north, 32.5 to the right of his course. He sees the mountain. So he's flying. He looks to the right, 32.5 degrees. There's the mountain. Okay. At that time, the plane is 6 kilometers from the mountain. This is 6, in other words. At this moment, when the plane looks over at the mountain at 32.5 degrees to the right of its course, at that moment, the mountain's 6 kilometers away from the plane. All right, then time goes on. A short time later, the bearing, now remember he's flying straight. He just keeps flying straight. A short time later, they told me flying a straight course. Short time later, the bearing to the mountain becomes 42.5. So a little bit later, say he's up to like here. He looks to the right. And his bearing is 42.5. What's 42.5? Is it this? No. It's this. Because that's from its course, huh? Right? From the blue line. From its course to the right, 42.5. Everybody get... So this angle is 42.5. And this one is 32.5. Right? We good with that? So far, so good. So, and the question is, how far is the plane from the mountain when the second bearing is taken? In other words, X right there. How long is that dotted green line? What is X?
7.5 kilometers.
So we good? We good to there? So let me give you a second to think about what you might do. Now we got a good picture. That's maybe 80% of the battle is a good picture like that. Now see if you can use some trigonometry. Triangulation is what they call triangulation. See if you can use that to figure out what that X is. How far to the mountain at that second green dot? What is X? Maybe another 30 seconds. Okay, what do you think? Law of sines, law of cosines, something else? What do we think? Law of sines, because we have a pair, don't we? What pair? Well, we kind of do. If we could get this angle, which is inside the triangle, then we would have that and the side across from it, the 6, we would have a pair. And we could do law of sines. Remember, you always want an angle and a side directly across from it. That's a pair. That's like A with A, B with B, C with C. That's a pair for the law of sines. Everybody with me? So I want to get this black angle in here that's inside the triangle. How do I get that? Subtract from 180. Does everybody see that? Because one whole side of a straight line is 180. You with me? If you're headed down and you turn it around and head up, that was a 180 degree rotation, wasn't it? If I'm headed straight to the back of the room, and I stop, turn, and head to the front of the room, that was a 180 degree flip, right? That was 180 degrees. So that means 42.5 plus whatever has to make 180 total, doesn't it? So I can find that other whatever by 180, this right here, is going to be 180 minus 42.5, which is, I don't know, 137.5 degrees. So this is 130, let me make that a little nicer. This must be 137.5 degrees. Good? To there. Now, I've got these two which are across from each other. This is an angle and a side directly across from each other, which means that's a pair in the law of sines. Angle and side across. And then I've got the x and the 32.5, and I can find the x. Side over sine of angle equals side over sine of angle across from it. Right? So that'll be x over sine of 32.5 degrees is 6 over sine of 137.5 degrees. There it is. Diagonal, diagonal. X sine 137.5 degrees is 6 sine 32.5 degrees. Last step to solve this thing for x is divide by the sine of 137.5 degrees, divide by the sine of 137.5 degrees. X equals, let's try it, 6 sine 32.5 divided by sine 137.5. I'm getting 4.77, or rounded to one place, 4.8. Answer D. Good? That's kind of amazing. It's like triangularization. Just by a one angle, then an angle later, knowing the original distance, you can calculate the new distance. Is that good? All is well? Questions on that one? All right, I want to get a couple more in if we can. Am I rushing you, though? Any questions on that one? Is that okay? All right. Okay. So number 4, solve the triangle. Round lengths to the nearest tenth and angle measure to the nearest degree. All right. So give that a try. How are we doing? So, I want to give you a minute there to think which one am I going to use? Law of sines, law of cosines? What am I going to use on this one? Yeah, how do you know right away it's law of cosines? Yeah, there's no pairs, huh? We have there's not A with A, there's not B with B, there's not C with C. There's just 3 different, A, B, and C. No matching pairs, law of cosines, right? We all good on that? No matching pairs. So no law of sines. Instead, use the law of cosines. So I'm going to use the law of cosines because there's no matching pair. We don't have A with A or B with B or C with C. So now when I use law of cosines, remember there's 3 different versions. You can have A squared in the front. You can have A squared equals whatever, or B squared equals whatever, or C squared equals whatever. How do you know which one you want to use?
A, because we have the angle A.
Yeah, because we have angle A And you always end up using the cosine at the end of the thing of the angle opposite it. Totally. And A is what we're trying to find. We have B and C, huh? So perfect. So we want to do A. So let's do that. So A squared is, remember the law of cosines? Any side squared is the other two sides, like Pythagorean kind of, squared, minus 2 times those other two sides times the cosine of what angle? A, yeah. The angle opposite what you started with. Start with A, you end with cosine A. Huh. Remember that? So A squared is B squared, which is 5 squared, plus C squared, which is 6 squared minus 2 times 5 times 6. Cosine of the big A, 70 degrees. All right, let's hit the buttons on the calculator. I'm getting 40.4787914. Use a lot of actually, then root it. I'm getting 6.36. Oh, and that rounds to 6.4. Answer A. 6.4, answer A. We good? All is well?
So,
Clarence?
basically, no, because I understand how you got the answer, but like what it's asking for. So so the way once it solves the triangle, it's just basically it's not talking about all the degrees. It just wants
Yeah.
when it says something like that.
Correct. Good, Clarence. Yeah. I'm just to save your time on the test, I'm not having you find everything. So I figure if you can get one of them, I know you can get the rest. Yeah. So this is exactly how I'm going to do it. Is I'm just going to have you do one of them. So yeah, we just find one side, done. I know you can find the rest. I just don't want to use up all your time. Make sense? You're right, because even though it said solve, which usually means find all three sides, all three angles, I'm just asking you for one.
I didn't really understand what you did before that step of like where you squared the A squared. I mean, like you would get normally 61 minus 60
Right.
cosines.
Correct.
Okay, yeah. And then would we subtract the 61 to A squared?
Good question. So 61 minus 60 cosine 7. Yeah, you can't subtract these, right? Because it's 61 it's like 61 minus 60x.
So you subtract that to A squared side, right?
No, I would just hit the buttons on my calculator. I would just type this into my calculator. That's how I got the 40.478.
So you, okay.
Literally type that in. 61 minus 60 cos 70.
A squared is already by itself on one side. So
Yeah, and then I just root it.
Okay,
After that. Good. All right, let's move straight ahead. How we doing? Good. Got a little more time. Okay, find the magnitude and direction angle to the nearest tenth of a degree for the given vector v. All right, so remember, how do we convert from an ij, so they're giving me ij, and they want me to convert to like magnitude angle. We've been going the other way today, but we did this direction last week. And you never forget anything we do, right? Yeah, Pythagorean's the way to start, finding the magnitude. Good. Very good. So let's start there. And so to find the magnitude, yeah, we did this today, didn't we? Square root of a squared plus b squared. That's how you find the length of a vector. Because the I and the J are just parts of a right triangle, aren't they? It's just back 5 up 12, isn't it? Back 5 up 12 minus 5i 12j. Right angle, it's a squared plus b squared is c squared. So the length of the vector is the square root of a squared plus b squared. So that's going to be what? Minus 5 squared plus b, which is 12 squared, which is square root of 25 plus, 144. I'm already jumping to the answer. 144. Which is the square root of 169, which is 13. So we got the magnitude, that's half the battle, or that's actually a little bit less than half. It's part of the battle. The magnitude of the vector is 13. So we got that. So It's not answer C, that's out. But the rest are still in the ball game, huh? The A, B, and D all say magnitude 13, which is correct. Now we got to find the angle. How do you find the angle? Let me put this thing on the axis system. So this vector is right here. This vector V. It's back 5, up 12, isn't it? Everybody good there? I got it, and I want to find the angle. Now, what angle? When they say the direction angle. See, they're saying find the magnitude V and the direction angle theta. How do I find a direction? What is a direction angle?
It's the angle from 0.
From 0. Well said, Pauline. It's the angle from 0. Yeah, so the direction angle means from here. Theta. This is 0 degrees. It means from 0 to that vector.
So D is out.
D is out? Yeah, it's got to be more than 90, doesn't it? Forget D. It's got to be more than 90. Is everybody good so far? That's what you want to be clear in your mind what a direction angle means. From 0 to the vector. From 0 to the vector. Okay, so how do I find that angle theta? From what? Don't I need to find, let's call this X or call it whatever you want. Don't I need to find this little angle inside the triangle first and then do the from 180 thing? Tangent. Yeah, right? Because that's opposite over adjacent. Remember? We said the angle inside a triangle is tangent inverse. I don't know if you remember, but we said a lot of things last week, but that was one of them. Yeah, whenever you want, when they give you the IJ thing, which they're giving me the IJ thing. Do you see how the tangent, remember, so TOA, opposite adjacent, tangent's opposite over adjacent? Remember that? So therefore that angle X is just going to be inverse tangent of 12 over negative 5. Remember that formula? The angle, now that's the X in the triangle. Once we get that, we're going to take away from 180. Like Clarence was saying, he's right. So far so good? So you find that little angle X by inverse tangent of Y over X, opposite over adjacent. Right? So hit the buttons on your calculator, you're going to get a negative thing. Tangent inverse of 12 divided by negative 5. So I'm getting X equals negative 67.4 degrees. Negative 67.4 degrees. Now, what does that mean? Negative? That'd be like down here. What does that mean, negative? Well, don't let that bug you. Remember, that's all the restrictions and how it can say it somewhere. Not whatever. It's 67.4. This X here is 67.4 degrees. That's what it truly is. 67.4 degrees. They're saying negative because they have to say it down. They can't go in second quadrant. Remember? So just don't worry about all that. 67, it's a reference angle. It's to the x-axis. See how that goes to the x-axis, 67.4? That's all I care about. That's the reference angle. So, okay, yeah, so what? Well, how do I find the direction angle, theta? That's from 0 to the vector. Everybody see it's from 180? Right? Together, that's the top of a straight line. That's 180, isn't it? So then we've got it. So theta will be 180 minus 67.4 degrees. 112.6. A is the answer. 112.6 degrees. Does that make sense? On that? Is that good? So that was a little tricky.
So is magnitude equal to the hypotenuse?
Yeah, magnitude is hypotenuse. Magnitude is hypotenuse, right? Because the length of a vector, a squared, b squared, c squared, huh? It's always the square root of a squared, but it's the hypotenuse. The length of a vector is the magnitude of a vector, is the hypotenuse. Yep, totally. Fair.
So just say just for kicks, like what if like it was like -5 and -12? Would we like
Yeah, good question. What if it was? What if it was negative 5 negatives, like down like that, and we got 67.4 or whatever, which would be the angle right there with the x-axis. So what would we do to find the direction? If this was the vector, right there, the direction, Claire's question is a good one. It'd be from here all the way to there, right? That it's always from 0 degrees to the actual vector is the direction angle. And if I knew this was 67.4 from the x-axis, what would I do to get the final direction angle? Wouldn't it be 180 plus 67.4, right? Because rotate 180 and 67.4 more. We'd add it at that point. Is that good? You okay with all those direction angles? So if you're a little rusty on those, go back and practice in the homework. You can redo more of those without messing up your grade. Let you go back in for practice. Does everybody know what I mean about that?